1,000 furnaces produce 1 million wafers? So you've probably seen an announcement like this. 1,400 furnaces, over 1 million silicon carbide wafers per year. It sounds massive, but what does it actually mean in physical terms? So let's slow down and do the math. Public information from Synlight mentioned 1,400 furnaces and production capacity exceeding 1 million substrates annually. No judgment, just numbers. 1 million wafers divided by 1,400 furnaces, that's roughly 700 wafers per furnace per year. Now let's translate wafers into crystal. An 8-inch silicon carbide wafer today is around 500 micron thick. When you slice a wafer, you don't just use the wafer thickness, you also lose materials doing cutting. So each wafer typically consumes around 0.6 to 0.8 millimeters of crystal height. Multiply that by 700 wafers. Each furnace must generate roughly half a meter of crystal per year. Half a meter per furnace across 1,400 furnaces. And that is what a 1 million wafer headline implies. And let that sink in for a moment. And remember, that is just geometric math. And we haven't even discussed equipment uptime, crystal losses, wafer yield, cutting efficiency, process stability, grade distribution. Those layers determine where the capacity becomes profitability. Yes, technology improves, yield increases, cutting loss reduces, but the physics still sets the baseline. So next time you hear big capacity numbers, don't react emotionally, do the math. Because in silicon carbide, real capacity isn't about how many furnaces you install. It's about how much usable crystal you can consistently convert into sellable wafers. And that difference can be very expensive to misunderstand.